Hello and welcome to the CAE with Armin channel. I'm Armin, and today I'll show you how to model the propagation of sound waves in both air and water domains using Comsol. We'll be working with the Pressure Acoustics transient physics and performing a time-dependent solution. For this simulation, I used a point source with an amplitude of 1 at 500 Hz and a pulse peak duration of 0.01 seconds. We will also observe the sound pressure of the acoustic wave in the air and water domains and label the domains with annotations. Let's get started. First, I'm going to click on Model Wizard. Since our geometry is two-dimensional, I'll select the 2D space option. We want to perform an acoustic analysis, so I'll expand the Acoustics menu, then Pressure Acoustics, and select Pressure Acoustics, Transient. Next, I'll hit the Add button. You'll see that the Pressure Acoustics physics has been added to our model. Now, let's hit on to the Study button. Since we want to analyze sound waves in the time domain, I'll choose the time-dependent solver and click Done. Now we are in Comsol environment. Let's start by creating the geometry. We need two rectangular domains, so I'll right-click on Geometry and select Rectangle. Alternatively, we could choose Square. Either option is correct for this example. I'll set both the width and height to 10 meters, and click Build All Objects to generate the geometry. Next, we need to add layers. Since sound propagates in a free field environment, we require perfectly matched layers to simulate this environment correctly. I'm going to expand the Layer in Settings window and set the thickness to 1 meter for the bottom, left, and top layers. Then, I'll click Build All Objects to update the geometry. These regions will assign as perfectly matched layers. Next, we need another rectangle. A quick way to do this is to duplicate the existing one and adjust its position to 10 meters. I'll go ahead and click Build All Objects again. We'll also need to shift the layer orientation from left to right. Now that everything looks good, let's move on to adding materials. I'm gonna right-click on Materials and select Add Material from Library. From the built-in section, I'm gonna add both air and liquid water to the model. After selecting, I will close the window. The left side of our model will represent air, and the right side will represent water, so I'll assign these materials to the respective domains. Now, as you can see, air is assigned to the left rectangle and water to the right. Everything looks good so far. Now, let's add the boundary conditions. First, we need to add a perfectly matched layer. I'm gonna right-click on Definitions and select Perfectly Matched Layer. We need to apply this to all the external boundaries to ensure that the wave propagates freely without any reflections. Next, let's add a point source. I'm gonna navigate to Physics, then under Points and select Point Source. I'm gonna change the source type to Gaussian pulse. For this example, I'll set amplitude to 1 and the frequency bandwidth to 500 Hz, and I'll leave the pulse peak time at its default setting. Now, we need to add the point source in the geometry. We can add a point by right-clicking on Geometry or selecting it from the tab. Choose a point in the domain. I'll change to point location to 10 meters, which positions it right in the middle of our domain. With the point defined, we can now assign the point source to it. We only need to select the point. It's time to generate the mesh. I'm gonna go to Mesh 1 and click Build All. You'll notice that the mesh in the air domain is finer than in the water domain. This is because the speed of sound in air is lower than in water, so it requires a finer mesh to accurately capture the wave propagation. Finally, let's set up the time-dependent study. I'm gonna go to the time-dependent step, click on Range, and enter the time range from 0.005 to 0.1 seconds. This range will replace the previous one. Now, I'll click Compute and wait for the solution to be calculated. The solution is complete. Now we can view the acoustic pressure results at any time we want. For example, let's select the first step, and by clicking on the arrows, we can move through the time steps. This shows us the acoustic wave propagation graph. However, the time steps are quite long, so it would be better to adjust the interval for more precise results and solve it again. I'll reduce the time step, but I won't click on Compute. Before we do that, let's add annotations to make the domains easier to identify. To do this, expand Acoustic Pressure, right-click on it, and select Annotation. For example, we'll place an annotation in the air domain and label it accordingly. Set a point for it in the Position section. Then, we'll duplicate this annotation, rename it to Water, and place it in the Water domain. Also, we need to change the position. With these labels in place, we're ready to solve the model again. Navigate to Study and hit on Compute. The solution is complete, and now the step sizes are properly adjusted for the sound speed. We can change the time steps and investigate the acoustic wave propagation more precisely. By changing the time step, the sound wave is slightly shifted. This concludes the tutorial. Thank you for watching. If you found this helpful, please like the video and subscribe to my channel.